Boys and girls, this is Mr. Manise here again with another super awesome video. In this video, I'm going to walk you through the test review for Chapter 5 on quadrilaterals. My disclaimer as always is do not come to this video and just watch the video and copy down the answers. I would like for you guys to work out the problems on your own, and then for the ones that you don't know how to do or you're not sure about, come to the video and iron out any misunderstandings or mistakes that you might have made when you check your answers. Okay, so here's what I got for the Clemson reference. One of my fellow teachers and friends got me this pack of Clemson Post-it notes, which I thought was pretty cool. Nice little gift from one of my friends and co-workers. All right, so let's jump right in. Number one, quadrilaterals. In the figure, the horizontal lines are parallel, and AV equals BC equals CD. Okay, so that means I can put a tick on each of those guys. They're all the same length. And that says find the length of JM. So I want to find this whole length here. This is a pretty easy problem. And our theorem says if we have a bunch of parallel lines and it's cut by a transversal and we cut each of those pieces into equal segments, then that means any other transversal will also cut it into equal segments. So if ML is 3, then LK is also 3 and KJ is also 3. And to find the whole length, I just add 3 plus 3 plus 3. And JM is going to have a length of 9. Okay, number two, the sum. Here we go. We're looking for these trigger words, and actually, this one actually should be, we'll put this in here, that should be interior. I'm not sure why that was left out. So this is asking for, saying the sum of the interior angle measures of a polygon with S sides is 2700. Find S. So this is the one where we got to work backwards. So they tell, usually we're trying to find the sum. And the formula for the sum of the interior angles is n minus 2 times 180. We're usually trying to find that sum. But this time they tell us what the sum is. They tell us that it's 2700. Okay, so I'm going to set this expression, n minus 2 times 180. I'm going to set that equal to the 2700. And now I'm trying to work backwards to back calculate what the number of sides is. They're using S's. I'm just going to stick with N's. It's the same thing. So how do I get N by itself? So I'm multiplying by 180. So why not, let's just divide both sides by 180. You could distribute the 180 to the n and the negative 2. You could do that, but that's just an extra step for you. It's easier just to go ahead and divide both sides by 180. So I'm left with n minus 2 is equal to 2700 divided by 180 is 15. And remember, 15 is the number of triangles that I can form, and the number of sides is always 2 more than that. That's why we have this n minus 2 expression. So I'll just add 2 more. And the number of sides will be 17 sides. Always remember to check your work. Go back in and plug it back in and make sure that 17 minus 2 times 180 does indeed equal 2700 degrees. All right, apologize for the streak going down the right-hand side of our test review. The copier machine didn't like us today. All right, which statement can you use to conclude that the quadrilateral XYZW is a parallelogram? Well, what do I know about parallelograms? The opposite sides are congruent, the opposite sides are parallel, opposite angles are congruent, consecutive angles, one big plus one little, same side interior angles are supplementary, that add up to 180, the diagonals bisect each other. Okay, so I'm looking for something that gives me one of those properties. Well, let's just go process of elimination. Okay, so if you tell me that YZ, okay, YZ, if you tell me that that is congruent to ZW, if you tell me the right-hand side is congruent to the bottom, that doesn't help me because that's saying that consecutive sides are congruent. That's not a quality, a characteristic or property of a parallelogram. That's true of a kite, that consecutive sides are the same length, but not a parallelogram. So I'm going to scratch that one out. All right, B says YZ. Okay, so the right-hand side is congruent to XW, the left-hand side. Okay, that's good. Opposite sides are congruent. That's true. WZ, so the bottom is congruent to ZY. Once again, I got the bottom congruent to the left. That doesn't help me. Okay, that's not a property of a parallelogram. ZN, okay, ZN. So this little piece of that diagonal is congruent to NW. Nope, that's not true. The diagonals bisect each other, so that means this little piece NZ has got to be congruent to that little piece XN, and NW has to be congruent to NY. But that's not what this says. This piece is not going to be the same length as this piece, so that's not true. So by default, it's got to be D. Let's just make sure. YZ, okay, Okay, triple tick is congruent to XW. Yep, triple tick. Opposite sides are congruent. That's true. And then YZ, the bottom, is congruent to XY, the top. Yeah, that's true. Quadruple tick, quadruple tick. So that's true. Opposite sides are congruent. Okay, number 4. This is one of the harder ones on the test review and the test. It says find the values of the variables. Variables, that means I got to find more than one thing. And the parallelogram, diagram's not to scale. Okay, so they give us this angle 102, this angle 35, got a couple of variables over here, and a z over here. What do I know about parallelograms, specifically the angles? I know consecutive angles are supplementary. Okay, big plus little have to add up to 180. I know the opposite angles are congruent. So if this guy is 102, this guy is also a big obtuse angle. That's also 102. So z is 102 degrees. That's pretty easy. Okay, what about these guys? Well, I'm probably going to have to use this 35. And this goes back to Chapter 2 stuff. You guys remember, two parallel lines cut by a transversal, alternate interior angles. Remember the z? Remember that? Me teaching about the z. Look for the z. Alternate interior angles in the z and the little crevice of the z are congruent. Well, if I were to extend these lines out, because it's a parallelogram, so opposite sides are parallel. Okay, well here, let me see if I can do this in a different color. I'll choose a beautiful orange. Here's my orange. Here's the z. Okay, in this case it's a backward z, but it's still a z. Okay, so the two angles in the crevice of the z, these are alternate interior angles, right? So they're across from each other. So if this is 35 degrees, then x is also going to be 35 degrees. Alternate, I'll just say alternate interior angles, AIT, alternate interior angles. And z is just opposite angles, or congruent. All right, now y. Y is the hard one. How do I get y? Okay, here's where you got to use the property of a parallelogram that says this angle, that's a big angle, it's obtuse, and this angle, this is a little angle. I'll put double purple arcs right here. That's a big obtuse angle. This angle down, the whole angle is a small acute angle. These are consecutive. Again, these are same side interior angles. The 102 and the double purple arc are same side interior. So they both got to add up to 180. Well, we just solved for x. X is 35. So I know that the 102 plus this whole angle, which includes the 35, plus the y that we're trying to find, both of those have to add up to 180. So basically what I'm doing is I'm taking 180 and I'm subtracting the big obtuse angle and then this little orange piece of the whole purple angle. So y is going to be equal to 180. Make sure y'all can see this. Y is going to be equal to 180 minus the 102 minus the 35. And what is left over is 43 degrees. So y will be 43 degrees. Go back and check. 35 plus 43 plus 102, yep, all that adds up to 180 because they're same side interior angles. Okay, so let's move on. Number 6, trapezoid land. Okay, so when I'm dealing with the angles in a trapezoid, there are two different worlds. There's the world of isosceles trapezoids and there's the world of regular good old-fashioned trapezoids. Does it say isosceles trapezoid? No, it doesn't. Do I see any ticks on the legs? No, I don't. So this is not necessarily, this is not an isosceles. We can't assume it's an isosceles trapezoid. If it were an isosceles trapezoid, then I can say the two base angles are the same. I can say these two big obtuse angles are the same, and these two small acute angles are the same. But since this is not an isosceles trapezoid, all bets are off. It's almost like there are two different problems. Just don't worry about the right-hand side. Let's just focus on these two angles over here on the left. And once we figure that out, then we'll come back and look at the two angles on the right. And once again, this is just like Chapter 2 stuff. A trapezoid has one pair of parallel sides. So this is just like two parallel lines cut by a transversal. What do we know about these two angles? You can use my little trick that I taught you. One big plus one little add up to 180. That's obtuse, that's acute. These are same side interior angles. So I just need to do 180 minus 39, and A will be equal to 141 degrees. Okay, so that takes care of A. And notice that 141 and 120 don't match because the base angles won't match in a regular trapezoid. So now let's ignore the left-hand side. Let's just look at the right-hand side. So once again, These are just two parallel lines. That was horrible. These are just two parallel lines cut by a transversal. Once again, these are same side interior angles. That's big, that's little. So I just do 180 minus the 120, and B has to be 60 degrees. Okay, 60 there, 41 there. Okay, number 6, rectangle. Okay, PQRS, PR, this guy in purple is 14x minus 9, and QS, the other diagonal, is x plus 631. Well, what do we know about the diagonals of a rectangle? Okay, they are congruent. There are only 3 figures where the diagonals are congruent. That's a rectangle, a square, and an isosceles trapezoid. Okay, so all I'm going to do is I'm going to set these two expressions equal to each other. So I'm going to have PR, I'm going to have that expression, the 14x minus 19, I'm going to set that equal to the other expression for QS, which is x plus 631. Let's subtract x from both sides. 13x minus 19 equals 631. Let's add 19 to both sides. 13x equals 650. Let's divide both sides by 13. And we get x is equal to 50. Okay, so is that what they asked for? That is not what they asked for. They asked for the value of x and the length of each diagonal. So I'm going to have to take this x equals 50 and plug it back into which one? Which one do I have to plug it into, the PR or the QS? It doesn't matter because they're both the same length, so it doesn't matter which one I plug it into. Plug it into the one that's easiest. The easiest one is just x plus 631. Okay, so I just stick in a 50 there, so 50 plus 631 is equal to 681. So both PR and QS are both equal to 681, and x is equal to 50. Okay, number 7, a road sign is in the shape of a regular heptagon is 7. Heptagon, what is the measure of each? I don't want the sum, I want each angle on the sign. Okay, so let's just come down here real quick and let's just come down here real quick and list out the 4 formulas from section 5.1. The sum of the interior angles is n minus 2 times 180. Okay, sum of the interior. If I want one interior angle, it's going to be the same formula, n minus 2 times 180, but I'm going to divide it by the number of sides. If I want the sum of the exterior angles, that's always going to be 360, no matter how many sides, whether it has 10 sides or a million sides. If I want one exterior angle, again, every time I want one of them, I just take the sum formula and divide by n. One interior is just the sum of the interior divided by n. One exterior is just the sum of the exterior divided by n. So they want, what is the measure of each angle on the sign? Okay. Once again, this is interior. I'm not sure why they don't have that word there. They want one of the interior angles on the sign. Okay. So we're going to be using this formula here. N minus 2, the n is 7 because it's a heptagon, so it's going to be 7 minus 2 times 180 divided by the number of sides, which is still 7. So again, you can plug all this in your calculator exactly the way you see it. You can go ahead and simplify first and say that's just 5 times 180 divided by 7, whatever you're most comfortable with. And that comes out to be 128.6 degrees because they say round to the nearest tenth. So each of your interior angles is 128.6 degrees. And I buy that because I'm talking about a heptagon, which is very, very close to an octagon. So here's a stop sign, an octagon. Looks something like that. So I buy that each of these angles is some big obtuse angle, 128, 129 degrees. So make sure you're doing that gut check to make sure your answer makes sense. Okay, back up here to number 8. Again, these kinds of questions on the test guides, you're just going to have to know your properties. So I would strongly suggest that you guys get out that graphic organizer and that formula sheet that I passed out to you and make sure you're real comfortable with each of the different properties of each of the different quadrilaterals. Alright, so which shapes share the property diagonals are perpendicular? Okay, diagonals are perpendicular. I know they're perpendicular in a kite, but I don't see a kite anywhere. I know they're perpendicular in a rhombus. All four sides are the same. Tick, 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 tick. Diagonals in a rhombus are perpendicular. So it can't be B, because that's not a rhombus. It can't be C, because it's not a rhombus. And it can't be D. So it's got to be a square and a rhombus. Okay. Yes, the diagonals are perpendicular also in a square. Tick, tick, tick. 90-degree angles for a square. Okay, so let's move on to number 9. If the measure of angle B equals the measure of angle D, okay, so if that guy equals that guy, and they both equal 47 degrees, okay, find the measure of angle C so that the quadrilateral is a parallelogram. Okay, well, opposite sides are congruent to parallelogram, so that's true. But I also need to know that consecutive angles are supplementary. This is little, this is big, this is acute, this is obtuse. These are same side interior angles. So I simply just need to subtract 47 from 180, and that gives me 133 degrees. So the measure of angle C is 133. Okay, that also means that angle A is also 130 degrees because opposite angles are supplementary. Opposite angles are congruent and consecutive angles are supplementary. Okay, number 10, this is the one where we have to find the mystery angle. I'm going to put an X in here even though that's not what they're asking for. They're asking for this outside angle A. But to find the measure of angle X, what I need to do is I need to find the sum of all of these angles. Now remember, this is not a regular quadrilateral. It's not a regular pentagon because all the angles are different. So I can't use the n minus 2 times 180 divided by n formula, okay, because these two formulas for the one individual angle only work if it's a regular perfect symmetrical polygon, which in this case obviously it's not because all the angles are different. So I'm going to use the sum formula, n minus 2 times 180. How many sides do I have? 1, 2, 3, 4, 5 sides, okay? So I'm going to plug in 5 minus 2 times 180. That's 3 times 180, which is equal to 540 degrees. Okay, so, oops, sorry, I can't see that. So the sum of the interior angles of every pentagon always adds up to 540. So that means to find the missing angle, I have to subtract each of these angles that I know from that guy to find the leftover missing angle. So I'm going to do 540 minus the 104 minus the 118 minus the 96 minus the 115. Punch all that in your calculator, and that comes out to be 107 degrees. Okay, so this guy right here is 107 degrees, but that's not what they asked for. They're asking for this outside angle, and remember, just like the one that was on the quiz, these two angles are supplementary. They form a straight line. They form a linear pair, straight line. So they have to add up to 180. So just do 180 minus the 107, and that gives me 73 degrees for the measure of angle A on the outside. Okay, let's continue on. Number 11. Okay, this is the kite problem. All right, so what do we know about a kite? We know that the diagonals are perpendicular, and we also know that the long diagonal is an angle bisector. So if I'm trying to find all of these angles, I know these two guys are 90 degrees. I already know that the measure of angle 2 is 90. Okay. If this is 36, they're talking about this little angle right here. I can come out to the side and redraw this little individual triangle. This is 90, this is 36, and this is angle 3. I know that the three angles of a triangle, the three angles of this triangle have to add up to 180. So I'll just do 180 minus the 90 for the perpendicular diagonal minus the 36. And the measure of angle 3 is equal to 54 degrees. Okay. They're also asking for the measure of angle 1. And remember that the long diagonal is the angle bisector. So if this guy is 36, then angle 1, measure of angle 1 also has to be 36 degrees. Okay, number 12. Find the values of x and y that make this a parallelogram. These are diagonals, and I know that the diagonals bisect each other in a parallelogram. So that means this piece has to be the same length as this piece. So I'm going to set these two expressions equal to each other. X plus 10 is going to be equal to 3x minus 6. And let's solve that real quick. Subtract x. 10 equals 2x minus 6. Let's add 6. 2x equals 16. So x equals 8. Okay, let's check that. 8 plus 10 is 18. 3 times 8 is 24 minus 6. They both have a length of 18, so that checks out. Now for the y's, again, we'll just set that expression equal to that expression. So y plus 1 is equal to 5y minus 7. So let's subtract y from both sides. 1 equals, subtract y from both sides. 1 equals 4y minus 7. Let's add 7. 4y equals 8. Divide by 4, and y equals 2. So x is 8 and y is 2. Let's check it. Okay, yeah, sorry, I was just looking at something different. All right, so if we check it back up here, 2 plus 1 is 3. That's going to length 3. And 5 times 2 is 10. 10 minus 7 is also 3. Okay, so that checks out. Alrighty, let's go back up here. Number 13. What is the sum of the exterior angles of a 32gon? You just got to know that the sum of the exterior angles is 360. That's a gimme. Okay, number 4. LM is the midsegment of trapezoid ABCD. And this is the one where we're going to have to use the formula. The midsegment is equal to 1/2 the sum of the two bases. AB is x plus 8. Okay. LM, the midsegment, is 4x plus 3. And the base is 264. Okay. So you can do this one of two ways. You can set it up to say the midsegment is equal to 1/2 of that guy plus that guy, the sum of the two bases, or just like we did with the midsegment of a triangle, I'm just going to come right out of the gate and double that guy. I'm just going to double it. 2. I've got 2 of those guys. 2 of the 4x plus 3, that's going to be equal to the sum of the two bases. That's going to be equal to the top, which is x plus 8, plus the bottom, 264. And I'm simply going to solve this. Distributive property, 8x plus 6 equals x. 8 plus 264 is 272. And then let's subtract x from both sides. 7x plus 6 equals 272. Subtract 6 from both sides. 7x equals 266. Divide both sides by 7, and we get x is equal to 38. Okay, is that what they asked for? What is the value of x? Yes. Now, for sake of time, I'm not going to plug this back in for the sake of time on the video, but you guys need to take this, plug it back in for x, get a number for the midsegment, plug this back in here, get a number for that base, add the two bases together, make sure this number is equal to 1/2 the sum of these two numbers. Always check your work. Okay, number 15. In the rhombus, the measure of angle 1 is 116 degrees. Okay, what are the measures of angles 2 and 3? Well, a rhombus is a parallelogram. We know opposite angles are the same, so I know that the measure of angle 2 is also 116 degrees. That's big, that's big. They're both obtuse. Okay, now to find the measure of angle 3, I need to first find this whole measure here. Okay, that whole angle. We know that consecutive angles in a rhombus or parallelogram are supplementary. So if I do 180 minus 116, that gives me 64. Okay, so this whole angle, that's 64, this whole angle, I'll do double arcs here, this whole angle is also 64. Okay, but then you also got to remember that the diagonals of a rhombus bisect the angles. So that means each of these angles have to be the same. So if the whole angle is 64, I'm just going to cut that in half, and the measure of angle 1 is going to be 32 degrees. So that angle is 32 degrees, that angle is 32, this angle is 32, that angle is 32, because they both have to add up to 64, since both of these angles are supplementary. Okay, so let's move on. Number 16. Find the values of the variables, and the lengths of the sides. So in a kite, I know that consecutive sides are the same. So these two, I can't do anything up here yet, because if I set this side equal to that side, even though, yes, I do have 2 ticks, I can't solve that because I've got an x and a y. But I can come down here and set these two expressions equal to each other because both of these sides are congruent. So I'm going to say 2x plus 3 This expression is equal to that expression. Okay, let's subtract x. X plus 3 equals 6. Subtract 3. We get x is equal to 3. Okay? Alright, so now that I have x, now I can go back up here and set these two expressions equal to each other. I have y minus 3, that length is equal to this length, x plus 4, but now I know what x is. I already solved for it. X is 3, so I just plug this in right there. Y minus 3 is equal to 3 plus 4. Y minus 3 equals 7. Add 3. And y is going to be equal to 10. Okay, so x is 3 and y is 10, but that's not what they asked for. They want the variables and the lengths. Okay, so to actually find the length, I got to plug this guy back in here. 10 minus 3 is 7, so that's a length of 7. And then this is a length of, if I plug in 3 here, plug this guy in right there, 3 plus 4, this is also 7. So the top two lengths are 7. To find the bottom lengths, again, I'm going to plug this in here. X plus 6, 3 plus 6 is 9. Plug it in here as well. 2 times 3 is 6, 6 plus 3 is also 9. So my lengths are both 7 and 9. Okay. Alright, number 17, you just got to know your properties again. Which of these properties is not a property of a rectangle? Opposite sides are congruent. That's true. Diagonals are angle bisectors. That is not true. Diagonals bisect each other. That's true. Opposite sides are parallel. Parallelogram. That's true. A rectangle is a parallelogram. But diagonals are not angle bisectors. That's only true in a rhombus and a square. What is the sum of the angle measures of a 33 gon? Okay, once again, you won't have to guess on the test. So that should be interior. So I'm simply going to use the n minus 2 formula times 180. And since it's 33 sides, I'll plug in a 33 minus 2 times 180. Plug that in your calculator, 31 times 180, and you should come out with a huge number, 5,580 degrees. Okay, based on the information given, can you determine that the quadrilateral must be a parallelogram? Well, let's add ticks and arcs to our diagram. xn, so this little piece, is congruent to nz. So a tick on xn and a tick on nz, okay. A tick on ny, double tick on ny, and double tick on nw. So yes, I can say yes, this is a parallelogram because what? The diagonals do what? They bisect each other. Diagonals bisect each other. This piece is congruent to this piece, and this piece of that diagonal is congruent to that piece. So if that is true, diagonals bisect each other, it has to be at least a parallelogram. So yes, that's true. Okay, coming down the home stretch here, the home stretch. Alright, number 20. In quadrilateral ABCD, the measure of angle ACD. Okay, so some of you guys get confused when you start seeing these three letters. It's not quite as easy as just saying angle C or angle Z. The measure of ACD, put your finger, your pencil on it. ACD. ACD. This middle letter will always be where the angle is. ACD. So this guy right there, that angle is equal to 2x plus 4. Okay. And then it says the measure of ACB. This guy, that angle is 5x minus 11. Okay, for what value of x does it have to be a rhombus? Well, you'll notice I put a single arc here and a single arc here. Why did I do that? Because one of the properties of a rhombus says that the diagonals are angle bisectors. These two guys will be the same, and these two guys will be the same. So I'm simply going to set these two expressions equal to each other. 2x plus 4, that angle has to be the same as 5x minus 11, the other angle. Let's solve for x. I always want a positive variable. So that gives me a positive 3x on the right. Let's add 11. 3x equals 15, divide by 3, and x is equal to 5. Okay, so is that what they asked for? For what value of x? Yeah, that's what they asked for. So x has to be 5. Check it. 2 times 5 is 10, plus 4 is 14. 5 times 5 is 25 minus 11. Yep, both 14 degrees. So both of these angles would be congruent. That's correct. 21. Okay, you're going to have a couple of these. When it says, what is the most precise name? Okay, listen to me very carefully. What I've been saying in geometry for months. You have to take your eyeballs and put them in the trash can. It does not matter what it looks like. It makes no difference whether, oh, that looks like a rectangle, so it must be a rectangle. You can't do that. You have to go based on what you're given, information. They've given me 4 ticks. Okay, so it's at least a rhombus. Okay, when it says the most precise name, you've got to go as far as you can go. You can't just say the bare minimum. You can't just say this is a quadrilateral, because although that's true, it's also something else. You got to keep going further, as far down the graphic organizer as you can go. All right, so it's at least a rhombus. I've got 4 right angles. Okay, so it's at least a rectangle. So if it's got 4 congruent sides and 4 right angles, what does it have to be? Yes, now this one, yes, it is what it appears to be, but that's not always necessarily going to be the case. Okay, number 22, what is the most precise name? Okay, what have I been given? Tick some opposite sides. Opposite sides are congruent, so I know it's at least a parallelogram. What else do I know? I don't know anything else. I don't know that these are right angles. I don't know the opposite angles are congruent. I don't know anything about the diagonals. The only thing that I can say is that this is a good old-fashioned parallelogram. Okay, well, what if I've given you something like this? Something that looks like a perfect, an absolutely perfect rectangle. Well, that looks like a rectangle. What is that? It's a parallelogram. I don't know anything about the angles. You haven't told me that these are right angles. So just because it looks like a rectangle doesn't mean it is. You know, if I give you something that looks like a perfect rhombus, it looks like all 4 sides are the same. You know, if I tell you, if I just tell you that the opposite angles are congruent, you can't say, oh, that's a rhombus because all 4 sides look the same. We don't know that. So the only thing I can say is that it's a parallelogram. Okay, so make sure you don't get fooled by your eyeballs on the test. Okay, number 23, for what value of the variables in the rhombus, or find the value of the variables in the rhombus below. Okay, so if it's a rhombus, all 4 sides are the same. Okay, so I can set the top and bottom equal to each other. I can set the left and right equal to each other. Which one is better? Well, if I set the left equal to the right, I've got 2 variables again. I can't solve that. I'm looking at a system of equations or something like that. But what if I just set the top equal to the bottom? If I say this side is equal to that side, I only have 1 variable. So why don't we do that? Why don't we say the bottom, 4x plus 3, is equal to the top? And that's only got 1 equation, 1 unknown. I can solve that. I just have an x I need to solve for. 4x is equal to 12 divided by 4, and x is equal to 3. Okay. All right, so now I can go back, just like in one of our previous problems, I think it was the kite problem. Now I can go back and plug in x here, and now I can set these 2 equal to each other. I can say 3y is equal to 5x, but now I know what x is. X is 3, so I just plug it in right here. 3y is equal to 5 times 3, which is 15. Divide by 3, and I get y is equal to 5. All right, let's check it. This side is 15. 4 times 3 is 12. 12 plus 3 is also 15. That checks. Y is 5. So 3 times 5 is 15. X is 3. 5 times 3 is also 15. Yep, all 4 sides are 15. So yes, that's a rhombus. Okay, and the last one. Find the value of the variables in the parallelogram below. If it's a parallelogram, I know opposite angles are congruent. These are obviously angles with a little angle symbol. Opposite angles are congruent. Consecutive angles are supplementary. Okay, I could say that this angle plus this angle equals 180. This is big and little, but again, that doesn't help me because I have 2 variables. But I can add these 2. Okay, that's little, that's big. So I can say y plus 3y. If I add those 2 angles together, they're supplementary. They're same side interior angles. Here's the transversal. Here are the 2 parallel lines. So those are supplementary. They have to equal 180. So y plus 3y is 4y equals 180. Divide by 4. And I get y is equal to 45. or 45 degrees in this case, because that's just a single angle. Okay, so now if that angle is 45, now I can say these two angles are supplementary. That's big and that's little. Sorry, this is a little blurry. Sometimes my webcam has to cut. There we go. Has to recalibrate. There we go. All right, so I can say this is big, this is little. One big plus one little has to equal 180. So 3y plus 3x equals 180. But once again, I know what y is. We just solved for it. Y is 45, so I'm going to plug it in right there. 3 times 45 plus 3x equals 180. 3 times 45, 3 times 45 is 135 plus 3x equals 180. Subtract 135 from each side. I have 3x is equal to 45 divided by 3, and I get x is equal to 15. The other way you could do it, I just thought about it, the other way you could do it is to solve for y. You could have just set these two opposite angles equal to each other. That actually would have been a little bit quicker. I could just say y little little. I could just say y equals 3x, and since we already found that y is 45, I could just say 45 equals 3x divided by 3, and I still get x is equal to 15. So that's actually a little bit quicker, which is one reason I like math so much, because there's multiple ways to solve the same problem many times. Okay, hope you guys enjoyed this video. I wish you guys good luck on the test, and we will see you on the next video.